Hi GOH, this is Unit 8, Lesson 1, and today we're going to talk about similar right triangles. So our last unit talked about similar triangles and the fact that their sides were in proportion, so we're going to move on from that, and this chapter is going to focus on right triangles and something called trigonometry. So if we look at example 1, I have these two right triangles. How can I justify that they are similar? Be clear in your explanation. Well, if you're looking at their sides, and we see these are corresponding sides, the ones I highlighted in yellow, and the ones I highlighted in green, and finally the ones that I highlighted in blue. And all the sides are scaled by a factor of 2. So all the sides in triangle DEF are twice as big, so they are scaled by a factor of 2. Or you can just say they're dilated by a factor of 2. So the triangles are similar by side, side, side. Or technically you can also say they're similar by side, angle, side because they also have that right angle in between them. All right, let's look at the values of the ratio. So I got BC, which is 3, AB, which is 4, all right, EF, which is 6, DE, which is 8, and those are both divisible by 2, so they also both reduce to 3/4. And then I have BC, which is 3, AC, which is 5, EF, which is 6. I'm just taking these right off the triangle. DF, which is 10, which reduces to 3/5. Okay, so those reduce to the same amount. AB, which is 4, and AC, which is 5. DE, which is 8, and DF, which is 10, and those are both divisible by 2, so once again they reduce also to 4/5. So it's not just the ratio of the corresponding sides that are equal, but also the ratio of the relatively positioned sides that are equal. All right, and that's important. That's really why trigonometry works, which we'll get into this week. So in 2, I have triangle DEF is a dilation of ABC by a scale factor of K. I want to algebraically prove that DE over EF equals AB over BC. So DE over EF, okay, so DE is right here. DE, okay, is going to match up with AB, and EF is going to match up with BC. So the way I do it is I take the pre-image and I multiply it by the scale factor. So I'm going to take that scale factor of K and I'm going to multiply the pre-image AB times that. And on the bottom, EF and BC match up. So I'm going to take that scale factor of K and multiply it by BC. All right. Now all I'm going to do is I'm going to sort of take those K's and I'm going to pull them out separate. So it's K over K, AB over BC. And K over K is just equal to 1. All right, so this just here equals 1. So basically I've done it. I've showed that DE over EF equals AB over BC. Okay. All right, let's look at some similar triangles. If we know that triangle MNP is similar to triangle EFG, MN, let me draw this. That's the first thing that you should probably always do. So MNP similar to EFG, so I put M on the bottom left, I put E on the bottom left, I put N on top, I'm going to put F on top, and G is over there. So MN is 10, NP is 6, MP is 14. What is the ratio of EG to EF? So EG to EF. All right, so since the triangles are similar, their sides are not only in proportion, but the ratio of those sides are in proportion. So EG to EF is really the same thing as MP over MN. And MP over MN is 14 over 10, so that's 7/5. Okay, if we need me to see the colors right here. So EF and MN and EG and MP. Okay, so you can see where they have the same ratio. Since they're similar, those sides will have that same ratio. So I can use the sides from the similar triangle to write the ratio for the other triangle that does not have any sides. So my answer is 7/5. Right? And I have that written at the bottom. What I just said, we can use the ratios of relative sides or the ratios of corresponding sides of similar triangles to solve a variety of applied problems. All right, so let's flip this over. A person who is 68 inches tall, all right, so here's my person, standing straight, is 68 inches tall, casts a shadow that's 54 inches. So a person's going to be a vertical line, the shadow is going to be on the ground. At the same moment, a tree, here's my tree. So this is my tree right here. This is my person. Okay, a tree casts a shadow of 18 feet. Again, shadows on the ground. What is the height in feet of the tree? All right, now these are similar triangles. Why are they similar? They both have a right angle. And the sun is creating the shadow, so the angle that the sun hits the person and the tree is the exact same angle. So these are similar triangles, therefore I can set up a proportion. So I have the height of the person, the shadow of the person, the height of the tree, the shadow of the tree. And then I just cross multiply. So 54 times x is 54x. 68 times 18 is 1,224. And then I'm just going to solve for x. So the way to solve a proportion, we did this in the last unit, is I'm just cross multiplying. Now I'm going to solve for x. I divide by 54. And the height of the tree, or x, let me not switch to h. The height of the tree, which I called x, is 22.6. So it's about 23 feet because it says round to the nearest foot. Okay? So these are applied problems that I can use. Let's look at 5. I have a rectangular picture, has a width of 4.5 and a height of 3. If the picture is to be scaled such that the new width is 6, all right, so let me draw a new rectangle with a new width of 6. What is the new height? So let me figure out what this height is right there. So again, these are similar, so I'm going to be able to set up a proportion. So I have 3 over 4.5, so that's the length and the width of the original triangle, and the length and the width of the new triangle. To solve a proportion, I cross multiply, so 4.5 times x is 4.5x. 3 times 6 is 18. Divide by 4.5, and x equals 4. So now I have that the new height is 4. And then they want me to find the length of the diagonal. So the length of the diagonal, this is my diagonal right here. I just figured out that this was 4. Well, I'm going to just use the Pythagorean theorem. So I have 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. That's 52 equals c squared. C equals square root of 52, and I want that to the nearest tenth. So you're going to do square root of 52 in your calculator, and I get 7.2 inches. All right. And then our last problem. One of the classic engineering uses for similarity is measuring the width of a river, because that's not really easy to do. You're not going to swim across the river with a tape measure, especially if the river is kind of wide. So to do this, engineers spot 2 points on opposite sides of the river, A and B. So here are my 2 points. And they then measure a distance of BD along the river, and then a length of DE that's perpendicular to the river. Finally, they draw a line from A to E and mark the intersection of AE with BD as point C. So basically, they are creating 2 triangles. Why are these triangles similar to each other? Well, look at them. They both have a right angle, and I've created these vertical angles here. So they're similar by angle. They both have a right angle, and they have vertical angles. So basically, I've created similar triangles, and more importantly, one of those triangles is on land 100%, so I can measure what I have there. So they tell me that BD is 225 feet. That BD is this whole line right here is 225. Well, let's see what else they're giving me. CD is 30. Well, let me do 225 minus 30 because I really just want to know BC. I just want to know part of that. That's 195, all right? So now I got this is 195. And DE is 12. And then I have my width of the river is X. So you can see I have the width of the river, X, and the distance, the other part of that triangle BC is 195. And then I have 12, and I have 30. Okay, so I'm taking this this triangle has been rotated around, so I'm taking the corresponding sides from each of these. If you can't see it, so this corresponds to the 12, and this right here corresponds to the 30. All right, so I have my proportion, and then all I do to solve a proportion is cross multiply. So 30 times x is 30x. 195 times 12 is 2,340, and I'm just dividing by 30. And I have now figured out that the width of the river is 78 feet. Done. Okay, so we'll work with these similar right triangles tomorrow, and then we will move on to trig.